You're about to see just how many boards are required to form this foundation. This is reinforcing steel embedded into the concrete. You can see how high the form boards are, and these are all strategically placed. That's also according to the structural drawing. This is what holds the house to the foundation from the big bad wolf. Ever wonder what's involved with building a foundation of a house? Well, it starts from the bottom and it moves upwards. Welcome to CMGT TV. My name is Ian Fung. I'm a high performance builder in the city of Vancouver, and I'm going to take you on a journey to build this duplex from ground zero to net zero. Let's talk about the foundation. The foundation is comprised of two different parts: the footings and the walls. And similar to the excavation, you have to know what you're building, where you're building it, and how big or how tall you're building it. So let's start off with the footings. We follow the structural plan and we build the footings, which is the base of the walls, all along where the plans indicate, and most importantly, following the points where the surveyor had laid out for us. There's an X on this corner. That's exactly where the corner of the concrete wall will be. This is how we know where to build this concrete foundation, because once we build it, we can't move it. Let's talk about pad footings now. So the difference between a spread footing and a pad footing is the spread footings take the uniformly distributed load of the walls coming down, spread across a 24-inch wide footing. A pad footing has a larger concentration of load coming down, requiring a larger footprint of where the loads can be spread onto the load-bearing soil beneath. So the next step after all the footings are in place is to get the walls put up. All right, looks like the rental form guys have just pulled up. They'll be putting their materials right in the center, so let's make some room for them. A lot of people ask me, why would we use rental forms rather than buying lumber from the lumber yard? You're about to see just how many boards are required to form this foundation. First of all, this wood is saturated in a quick release oil, so they can be peeled off of the foundation easier. Secondly, all the pieces are fitted with hardware, so they join together at the corners with just a simple rod, almost like a hinge. Thirdly, look at the condition of the boards. They're not in the greatest condition. After a couple of uses, they get all banged up like this. Lastly, the cost. Look at how much material there is. If you were to cut all your plywood down to small panels like that, it's gonna be hard to reuse small pieces. Let me know how you do on your site. All right, day two of the formwork. Let's check it out. All right, we have the outside wall forms installed over top of the footings, and we have it all along the entire perimeter of the building. And the reason why we put the outside boards on first and have the inside ready to work on is because next guys coming in are the rebar guys. And what they want to use this area for is almost like a clean canvas to work with. They'll be putting in large nails, like 5 inches long. Those nails will be suspending rebars depending on what the specifications and the plans call for. So they'll be suspending along the walls, checking along the footings, how many rebars go on the bottom, usually 2 or 3 rows. The guys will be continuing to mark all their level lines, so when the rebar guys come along, they know exactly what they're working with. Let's check along this wall, for example. Here represents the top of the concrete. Everything below here is where the work's gonna be taking place. Now, it's always good practice for the builder to study the structural plans in detail, highlighting the areas, showing the footings, knowing how much rebar goes in there, the thickness of the wall, the spec of the concrete is going in. Of course, the framers are gonna know all this, but it's always better that the contractor knows this so he knows exactly what's going on as the work progresses. In my case, I have highlighted all the areas on the plans, the girder locations and the girder specs and the trusses, etc. Everything that goes into the structural is very important to know ahead of time so you can also plan for the rest of the trades as they come in. Let's check along this wall, for example. You can notice a sheen of oil on top of these boards. It's actually quick release oil, or AKA diesel. It's been applied to these boards so that once the curing of the concrete takes place, this oil has been applied to it. It makes it much easier to release the boards. You don't have to fight them off if they were just dry plywood. Okay, so as for the interior walls, most of these will be very short, maybe coming off the ground, maybe a foot or a maximum 2, with exception to the crawl space walls. But what you see here is what's gonna be poured in place. Let's finish up what we're doing today, get this canvas ready for the rebar guys, and we'll greet them in the morning. Okay, it looks like the reinforcing guys are here. Let's check out their work. You ever wonder what's inside your concrete foundation, aside from the concrete? This is rebar. This is reinforcing steel that's embedded into the concrete walls before the concrete actually gets placed into the formwork. Let's talk about this. So concrete alone has a lot of compression strength, but very little or no tensile strength. And what does that mean? It can withstand all the forces being pressed on it, but it has very little strength when it has a force pushing against it. For example, the side of a wall. This is why rebar is inserted and embedded inside the concrete walls. Now, in order for this wall to act for compression and tensile strength, we have to follow the engineer's specifications on how to place these rebars. According to the drawings, he's got double bars on the bottom, so double 15M bars. This is the size of the cross section. It's running along the bottom of the footings, double 15Ms on top, and he's got a grid pattern, 16 inches by 16 inches. He also has vertical bars, which run from the top straight down to the bottom, and hooks or a J-hook into the side of the footing to tie everything all together. So now we know what's inside the foundation. What about when the house sits on top of the foundation? What component ties the house to the foundation? This is where these new straps come in. This part is exposed. This part is completely embedded into the concrete, so it's got a good grab on it, and you can never pull this out of the concrete. It's like, you know, when Thor pulls that hammer out, well, same thing. You cannot pull this thing out of the concrete. This exposed piece of strapping, where the holes are, gets nailed onto the sheathing, and behind there's got to be some kind of a point loading, and that holds the house to the foundation. We'll see that in upcoming videos, but this is how it looks like before the concrete's been placed. These are all strategically placed in all different areas where point loads are, and that's also according to the structural drawing. Everywhere it says this structural hold down 14, this is what the SH14 means. You've seen the three pigs, they have their own house. Well, all the houses get blown away. Well, the last house stayed intact because it was stuck to the ground. In modern houses, this is what holds the house to the foundation from the big bad wolf. So this covers what goes on the outside of the house. Let's talk about what goes inside the middle of the house. Oftentimes, we have a structural load-bearing wall that runs down the middle of the house. We have the same double 15M bars on the bottom. Look at this. We have a bigger point loader here. This calls for a much bigger pad footing. And inside this pad footing, the engineer calls for a 5x5 grid, making somewhat like a 5x5 checkerboard. This reinforces this entire pad. This all ties together with the rest of the footings to make everything continuous. One last thing we're gonna do is determine the height of our wall. So this pour strip, this is a level line, this determines where the concrete stops. So when the concrete guys come in, they will dump the concrete in here and trowel to this level finish. So now you've seen what's inside of a concrete wall. We're gonna wait till the engineer comes and inspects everything. So let's wait for the engineer and let's get that pass. Okay, last day of the formwork. The guys been working hard, the weather's been on our side. Let's check it out. Now that you see the entire site with the formwork all put up in place, you can see how high the form boards are, markers for the heights of the walls, rebars are in place, tie bars are also an insert. Let's get right into that details and talk about every single component. So what we have here is an entire wall that's completely ready for concrete. We remember putting up the one side of the panel boards, reinforcing it from the inside, and now we have the other side of the board installed. Just imagine the amount of force of the concrete once it gets dumped in here. It wants to hit the ground, and it also wants to expand, especially when you start vibrating the concrete. How do we keep this entire wall assembly together and stopping it from expanding and exploding? That's where the ties come in play. Let's go have a closer look at those ties. So the best way to describe how the ties would work is to look straight down the cross section of a wall. This is where the concrete comes down. These are the quick strip ties. What you want to do is you will slip these through the form boards. There's holes coinciding on both sides of it. This little slit right here is where you slide the bars. These bars get slid through these holes continuously along the wall. They join one another, creating kind of a hold so that when concrete wants to be dumped in here, it has with all the tendency for it to burst open, these bars will hold them in place. Can you imagine stripping these off after the concrete dries? This is where you gotta hit it hard enough with a hammer. See, this is the weak point there, and it snaps off. That's why they call these quick strip ties, because when you hit it, it snaps off. That's it. The whole board comes off after all these ties have been hit. The whole board peels off the wall, and you have a nicely poured concrete wall. Now let's go inside the foundation area. Inside the foundation, you'll see a whole bunch of short walls, similar to the outside walls, just built a lot shorter. We talked about blockouts, giving access for pipes to run through. We covered pad footing. This is how it looks like before it's poured. So what's next? We pour concrete. When's it happening? Tomorrow morning. Did we pass inspections? Absolutely. What do we need to pass inspections? The engineer letter. We also need an updated geotech letter. City inspector came in and checked that we laid everything out and we placed everything according to where the walls are supposed to be. There we go. Certificate of inspection passed. Concrete's booked for tomorrow morning, 8 a.m. Let's get some sleep. Let's go.